Hi, this is Abel, the Controls Freak from thecontrolsfreak.com. This video is going to be about overview of a central energy plant, aka chiller plant or CEP, or whatever else the engineers decide to call it. Let's take a look inside here and put together some pieces of the CEP and describe a little bit about how they all work together. Alright, first stop on the list is going to be the chiller. Can't have a chiller plant without the chiller, so let's start there. Right now we've got my little picture here of a McQuay centrifugal chiller. There's many different types of chillers, however we're not going to go into that in this video. Right now we're going to stick with a centrifugal chiller and just briefly talk about the 3 points or the 3 parts to the centrifugal chiller. Very simply, they're the compressor, which is right here, and also mounted back here on the back side there where you really can't see it is the compressor. And then you have an evaporator section, which is typically the bottom barrel here, and the condenser section, which is your upper barrel here. These 3 pieces are the main parts to a centrifugal chiller. Now there's many other facets and refrigeration cycle and all that good stuff, but I tell you what, as a controls freak, I don't spend too much time on that kind of stuff. There's a lot of resources out there. What I concentrate on is bringing the systems together and actually controlling them to do what they're designed to do. So let me just clarify on the evaporator section and the condenser section. These lines right here represent water lines. Now on the condenser side, these water lines run to the cooling tower, and we'll talk about that in just a second. This water here helps cool the refrigeration cycle. So instead of the condenser unit on the outside of your house that's blowing air, this is actually using water to cool that side of the chiller. On the evaporator side, we have water lines as well. These water lines actually run into the building through the coils that are inside the air handler units, or essentially air conditioning units inside the building. One other thing to note about chillers is that in these barrels that you see here, there's many different bolts that come across here that seal up the 2 ends of this barrel. Inside the main portion of this barrel, these water lines that you see here are actually long tubes that run the full length of the barrels. And so if you ever hear somebody saying they were changing out tubes or they have dead tubes in the barrels and so forth, these mini tubes, and there's many of them. I've seen some chiller barrels that had literally 100 or more inside the chiller barrel. So there's tiny little tubes all throughout this chiller barrel. And that's where you get the water running back and forth through this barrel to do the heat transfer. So just a little bit of extra of the chiller. Let's move on to the next step. Alright, here we've got the cooling tower, and right now we've got 2 images in front of you. You've got a diagram of the cooling tower as well as an actual cooling tower. And I do apologize that they don't exactly match, but they're still very similar in function, and we'll go over where all this air and water is going to and how they work on both the image on the right as well as the diagram on the left. So the cooling tower's purpose is, as you remember, the condenser side of that centrifugal chiller. It's going to have hot water coming out of it. And what we need to do is cool down that water to help keep the chiller cool on that side of the refrigeration cycle. So here in my little diagram, we have the hot water that's going to be coming into the cooling tower. And essentially it either has a pipe that just lets the water drip down the side of the tower, or sometimes they have actual little spray heads that actually spray the water and disperse it in a wide spray across the cooling tower. This diagram here kind of represents one where it would just hit this top here and it would just kind of rain down across here. Now the purpose of raining down across just by itself would actually help cool the water down just with the air naturally coming, with the water pouring out and going across these little fins that are here. That'll actually give it a little bit of cooling. So sometimes you'll actually use that as a first stage of cooling. A second stage of cooling, or sometimes the first stage, and depending on the control sequence, will be this fan that we have right here. Now this fan, once turned on, actually pulls air in from this direction and then shoots it out the top. And as that air comes across this water, it helps cool it down. And then sometimes you'll see, like early in the mornings when it's nice and cool out, big plumes of steam coming out of rooftops and so forth. Well, that's exactly what you're seeing. You're seeing all that hot air coming out the top, and of course it creates steam and when it's cold outside. So as that water falls down, it goes from being hot to being cold. And usually there's a basin down here, a cold water basin, and that water gets sitting here, and sometimes 1 or 2 feet of water. And then there's one pipe that's right here, which would be your return water, and that would actually go back to the chiller. And that just kind of completes the entire cycle there of the hot water coming in at the top, getting cooled down, and then getting sucked right back, going back towards the central plant. This, in effect, is going to help cool down that condenser tube. On this side here with the picture, we can see a representation of what it looks like on the outside. Now, this diagram normally represents a tower where you would see the louvers on the sides up high. These louvers are actually down low here, and it allows the air to be sucked in at the bottom and then shoot out the top. And normally on a tower like this, the inlet pipe would be somewhere here, and then the basin would be somewhere here, so not as big as the one depicted here on the left, but essentially it works exactly the same. You have a fan here at the top blowing air out the top and bringing the cold air in at the bottom and coming across the water to help cool it. Same thing. This motor here usually has some sort of a gearing or this motor here usually has some sort of a gearing that then spins the fan blades here that are inside the shroud right here. And that is basically what a cooling tower does. Not too difficult. A lot of the control strategies that deal with cooling towers is when you have multiple cooling towers side by side, and either you use them as a staging where you have a cooling tower 1, 2, and a 3. So as it gets warmer, you call on another tower, another tower, another tower. Or in the case of just having multiple towers, and it's dedicated for when you have one chiller, you run one tower. When you have 2 chillers, you run 2 towers. These are different strategies that you can have, as well as if there's one tower with multiple fans, so you might have 2 fans on the cell. This is a cooling tower cell. One other thing you can have for cooling towers is a bypass. What a bypass valve does is normally that hot water comes in here at the top, and let's say it's coming from the central plant, and this will be the central plant over here. But instead of going through the top here, what they'll do is they'll tap in another pipe right here, and what they'll do is they'll put a valve here and a valve here. Sorry, my drawing skills are lacking right now. And these 2 valves will be linked together with one actuator. And what they'll do is they'll bypass the water. Instead of going across the top and coming down and getting cooled, what they'll do is they'll force that hot water directly into the basin, and in the back over here where the pipe is cooler and the cool water is getting sucked to go back into the CEP, going this direction. Therefore, they're putting the hot water directly into the basin without going down across the tower here and getting cool. They'll just bring that right into the basin of water and get sucked back in. The reason why they would do that is in cases where it's very cold outside, and by running it across the tower you get it too cold. And that can actually hurt a chiller. If you make the water too cold, the efficiency of the chiller actually degrades. It's kind of like your unit at your house. If you run your AC when it's really cold outside, bad things start to happen. You're running the refrigeration cycle the wrong way. So essentially, they use that warm water to come right back in and send it back to the chiller, but still maintaining the required set point, whatever that may be. So that's one other strategy that's used with cooling towers. We've already talked about the chiller here, and we've also talked about the cooling tower. Some other little items besides the pumps that we put here is the air handler. This is an example of a packaged unit air handler that would be inside the building, and you'll see the little pipe connections here, and that's the cooling coil that's inside the unit. This green pump is going to represent our condenser water pump, and typically they use green piping or green to represent condenser water. And then this little blue pump here is going to represent our chill water pump, and they usually try to use blue or white for chill water piping as well. What we're going to try to do now is connect the piping all together, and see if I can get some colors here. Alright, we're going to draw the chill water piping coming out of the chiller with the light blue because it's freezing cold. And we're going to draw that coming into the bottom of the coil. And that's actually kind of important. Typically you want to pipe in the incoming water going to the bottom of the coil. And the reason why they do that, and it'll help you identify what piping is what, is that way when you fill this coil with water, you always want to have the outlet of the water coming out the top of the coil. And the reason why is you want this to fill up with water before trying to pull it out. It's possible if you were to supply this coil with water coming into the coil from this direction, that the water may not actually fill the coil and you'll get air in this coil, which would mean that you're not going to get cooling on the upper portions of this coil if there was just air there, and water would flow in and then come down and get sucked out the bottom. So the reason why they fill it up from the bottom is that way you make sure you pressurize the coil and get all the air out of that coil. Alright, so we've got the chilled water coming at the bottom of the coil. Now we want to draw the water coming back out of the coil that's ready to go back to the central plant and get cooled down again. So that'll be this darker color here. And we'll send it this direction. And I'm sorry, pipes don't normally go to diagonal slant like that, I promise. But they comes into the inlet of the pump. And in case you're not familiar with the pumps, if you looked at this type of a pump here, the inlet is actually going to be this horizontal type here. And there's an impeller in here, so you kind of imagine it like a boat. And a boat propeller, but this is an impeller, will actually draw the water into the center portion of it and then spin it around and shoot it out the top here. And this is going to go right back inside to the chiller. So now we've pretty much completed the chill water piping. The water comes into the chiller, comes out cold, runs through our coils. This could actually branch off and probably hit multiple air handlers all throughout the building. But once they come back, they'll come back on the chill water return. And this is, let's go ahead and label that. This would be the chill water return. And this here is the chilled water supply. And this here would be the big loop. It would go through the pump, through the chiller, and back to the air handlers and so forth. On the condenser water side, you'll have the hot water coming out of the chiller. And we're going to draw this one as if it's coming into the pump. And it's going to come out the pump and come into the top of the tower right here. So that hot water is going to come across, get cooled down with the fan on, back into the basin, and from the basin it's going to get sucked back out and come back into the chiller right there. Now we've actually completed the condenser water, so I'm going to label these as well. We're going to have condenser water return, and then we're going to have condenser water, writing too fast here, condenser water supply. Now there might be some questions, well, how do you know the difference between the supply and the return? Well, this is how you need to look at it. If we're talking about chill water here, chill water supply is you're saying you're supplying chilled water. So that's actually going to come from the chiller because the chiller is what's supplying the cold chilled water. Therefore, the water leaving the chiller is going to be chill water supply. Now, you go on to the other side where the condenser water is, you'll notice that the water coming out of the chiller is the condenser water return. Well, the reason why is because the cooling tower is what's actually affecting that condenser water, and it's the one supplying the nice cold condenser water. So that's why we call that the condenser water supply, because the cooling tower, which is the condenser side of the loop here, is supplying condenser water to the chiller so it can use that to transfer heat. And therefore the hot water coming out of the chiller would be the condenser water returning to the cooling tower for the cooling tower to cool it back down. Hopefully that makes a little bit of sense there. And then that is pretty much the central plant overview. Now granted, there is a ton of other variations of equipment. There's multiple pumps, multiple chillers. In this simple diagram that we have here, you'll probably have anywhere from 8 to 10 different valves spread all throughout here. So This is just a very generic representation of what parts connect to what other pieces of equipment. So stay tuned. We'll come out with more videos with more detailed instructions and hopefully find some better images and piping configurations. Once again, this is Abel, the Controls Freak at thecontrolsfreak.com. Come visit, leave some comments, throw some thumbs up, rate it, do whatever you need to do. Let's interact and ask some questions and get some answers for you. Take care.